How much of that have you actually developed this weekend? You showed us a website and all of it.
Yeah, the whole website.
The website's a sort of working demo. It does actually do the plots live, so it's not just a mock-up. And credit to these guys, Pierce in particular, who struggled with maths and got it nailed down enough to say, look, we can do this. So we're not making this up. We did actually put some maths in and get some results live, which was, I think when we first looked at it, we thought the maths was going to kill us, and then we started with some academic help.
More assumptions.
Yeah, exactly. Some of the academics, George Fraser yesterday, was very helpful in saying, actually, don't worry about this, don't worry about that, and we got it down to something that can kind of prove a point.
So your diagrams, are they a composite of lots of measurements, or are they singular measurements somebody's made? We get these like outlines, just like tracing.
Well, we didn't.
Sorry.
Yeah. We didn't get an opportunity to make any observations.
No, is that an example of one person's measurement?
That's lots of people taking measurements.
So each line on the diagram would be one person's.
Okay, but if you know, so this is a regular object, can you not then, because since you've got these lines which are vectors, can you not then just stack them and use statistics to give yourself an error on your side?
The occultation of any one asteroid is unlikely to occult another star in any time in the near future, and they're tumbling in space. So you really have to have a lot of people doing it once at one occasion to get anything out of it. And if you look at some of the previous data that other astronomers have done, sometimes you only get like 2 measurements. Well, it would be enough to band the sort of ends of an asteroid. We wouldn't tell you very much about it, but the moment you get, say, tens of people, you do begin to actually see a picture of it. An interesting sort of anecdote is prior to space probes visiting the asteroid Ida, there'd been speculation that asteroids might have moons. And there was some anecdotal evidence that I read about from amateur astronomers that when they took this route, they sometimes saw momentary blink-outs prior to the main event, and people concluded that maybe there were moons. I forget which probe it was that went to Ida, I can't remember, but there it was with a large asteroid with a little tiny moon sitting next to it. So yeah, maybe that's what people saw.
So your restricting them to measurements, but is it to do with how far space they are that makes it better? Is it so if you've got regular distribution measurements on let's say the northern and southern hemisphere, so you catch the northern transitions, that will make your measurement better?
The more measurements, the better.
Or is it like a temporal thing? So whatever's making measurement with the telescope, if that was faster, say, so you make more measurements on your end, would that to increase your accuracy, or is it literally just?
Well, technology.
You can only make one measurement.
Only one individual can only make one measurement. It's like
you're taking the time that the star is eclipsed and the time that it reappears again.
So literally,
that is it.
Just the transition in your view.
And you're using that coupled with the speed of the asteroid itself to get a distance, so that you're getting the size of the asteroid when it's tracing the shadow. And then you're aiming to get as many people perpendicular to the path of the asteroid to create a shadow. I think the picture, you get people in one single strip, and then you can actually pick up a shadow.
You have to be in that track. Sometimes that track's big, sometimes it's small. Because the starlight is effectively coming from infinity, the size of the track will be the same as the size of the asteroid itself. So if Ceres or something sails past, then you'll get a 400-kilometre size track and lots more people can see it. But everybody who observes it needs to be either in that track, and it's nice to have 1 or 2 people just outside to give the sort of upper and lower bounds of it. But you do have to effectively be in the track. And
are you using like stationary heavy bodies bright enough to be?
Yeah, we did some research.
They're not moving essentially.
Yeah, they're stars. They're not moving. But
in the same instance, you not then use 2 stars because of different point of view it will transition.
It's very rare to get one asteroid transitioning a star and then doing another one very soon. It just doesn't happen very often. It's a sort of short answer. There are something like, I think we worked out there's sort of several thousand observable occultations every year from somewhere on Earth. So given the number of asteroids, which is in the thousands, hundreds of thousands, and the number of stars, you can see you've only got one chance when there's an occultation really. And if it happened at sort of even say an hour later, the asteroid might have rotated, so you're not really getting an accurate snapshot.
Yeah, so the background behind what we're doing is that the occultations are predicted on websites. So all we're doing is recording other people's measurements. Everyone knows when they're going to happen. So if on the rare occurrence there's going to be two of them, everyone will know that, everyone will record them.
So how also part of this then to try and sort of bring awareness among amateur astronomers?
Yes.
Yeah,
As well.
it's for amateurs, because this is a very exclusive club at the moment, and the people that do it don't need this, but we're trying to get amateurs in their back gardens doing it.
If you look at the software,
yeah.
the software that's out there, which for the sort of semi-pro kind of amateurs, it's scary stuff. In actual fact, at the simple level, all you need is your location, and it could be based on GPS if you wrote a native app, and the start and stop time that you observed of the occultation. So it's 3 bits of data, which I would say is well within the capability of an amateur astronomer. You can observe occultations with good binoculars in some cases. There's plenty of opportunities.
At the moment, there's lots of different observing groups that all gather their own data in different ways and work out diagrams themselves. This would sort of provide a centralised way of getting data from lots of different people.
How do you consider this? If you've got a rotating body,
Yeah.
how do you know what the orientation of the asteroid towards the Earth is?
How do you know?
What the orientation of the asteroid is to the Earth? If you've got an observation that's actually pointing towards you, it's a lot thinner at that point.
Effectively, in terms of time, you're treating the observations, because they all happen within a period of a couple of minutes typically.
I was thinking that gives you one dimension that
True.
at that point,
It's a profile.
the observation is only pointing towards you. Next year,
True.
it's actually rotating around.
True. It
So
is
what the size?
a shadow. At the end of the day, it's a two-dimensional shadow. That's all you can expect to get out of it. In theory, typically a track that went right across, sort of straight through across the Earth, typically that would last about 20 minutes. So in theory, if you had some people in London and some people in LA, 2 groups, you might get a little bit of 3 dimensions, but it's not.
It wasn't something like that. It was, how do you know during that 20-minute observation it's actually pointing towards you? Next year, it's now side on. So is your width 100 kilometres?
You wouldn't get to next year. You wouldn't get to next year. You've got one chance.
I think it's just a point of interest for the amateurs to see a shadow.
It's not 3D. It doesn't
What's
give you.
the purpose of finding the size?
It gives you the shape of it.
So what? Will give you a projection?
It's fun. and I think particularly relevant to find out, because it's always been speculated that asteroids might not just be potato shaped, it might actually be different shapes. And again, you're only getting a profile, a 2D profile, but finding out it's 2 objects or it's a figure of 8 shape like 2 Tartis is again quite interesting. Yeah, so no, you don't get 3D out of this.
For an object that you couldn't measure at all any other way, it's useful to be able to get something, even if it's just
What
one.
about other mechanisms for observing? What about optical?
They're so small that you can't really see them directly.
Like we said, you can use radar or infrared, and they're not accessible to anyone.
Radar, when you get Earth crossing ones, you can radar image, and there's some quite good pictures of that, but they have to come very close, within a moon's distance to get anything serious. But this, in theory, this could work at any distance, provided you know there's going to be an occultation.
Thank you.